packet. Luna, can you hit the light, please? All right. So yesterday in our journal entry, so the 3.1 journal entry, we talked about two different forms. One of them was standard form. The other was factored form. When you're dealing with writing functions from graphs, the easiest form to use is factored form. Why do you think factored form would be the easiest to use if we're looking at a graph? What does factored form typically already give us? Anyone remember from yesterday? What key features does our factored form typically give us? Corey. It gives us the roots, or what's another name for roots? The x-intercepts. So we can find the x-intercepts on a graph and figure that out with the factored form. All right. We can also use what about the roots to figure out what the exponent is. If we're looking at the graph, what can we use to figure out the exponents connected to the roots? We did a whole activity on it yesterday. What activity did we do to figure out, if we're looking at the graph, what the exponents of the roots are? Or the factors, exponents of the factors. What do we do for the warm-up today? We were looking at the dance moves, guys. So the dance moves will help us figure out those exponents. All right. So remember, when you're given this set, your factored form, if these were your roots, your factored form will look something like A is equal to X minus R1, X minus R2, so on and so forth. So remember, you're doing the opposite signs based off of whatever your root is. So if your root is, so for example, if your root is equal to positive 3, what's your factor? So remember, your factor will be what's in the bubble. What's your factor? X minus 3. So remember, you switch the sign, put it after an X. What about if your root was equal to negative 5? Someone tell me what the factor is. X plus 5. All right, and that's essentially what you're doing. Another way to convert is, remember, you can figure out a root by setting the factor equal to 0, solving for X. You can do it backwards. You could set X equal to the root and then get 0 on one side, which how would I get 0 on one side? You would minus the 3 to the other side. So X minus 3 is equal to 0, and there's my factor, X minus 3. So multiple ways to figure it out. Now, writing functions is based off of a couple of things. It's based off of the degree of the function. Who remembers what degree means? We talked about this yesterday. Maddie. So when you add the exponents, but it's typically in standard form, what's typically the degree? So factor form is when you add up the exponents. In standard form, or ax squared plus bx plus c, the degree is usually the what? The highest exponent. All right. So it's usually based off the degree. It's also based off of the end behavior. And it's based off of its dance moves. All right. So we're going to go ahead and write some functions. And they're going to tell us our roots. They're also going to tell us some other things that go on. So we're going to determine a quadratic function where the roots are negative 3 and 4. And it passes through the point to negative 50. And we're going to write it in standard form. Before we even write in standard form, we need to figure out what it is in factored form. So, first things first, quadratic function. What's it typically look like, graph-wise? It looks like a parabola. So if I want roots of negative 3 and 4, I'm just going to go ahead and graph those x-intercepts. So I have a root of negative 3 and 4. Now, the point 2, negative 50, we can kind of guess where it is. So we're going to guess the point 2, negative 50 is about here. All right. Given where that point is and where your roots are, do you think this parabola will open up, down? What do you think? So do you think it'll open up or open down? Based off of where all 3 points are, what kind of shape does it look like it's going to form? It's going to look like it's opening up. So if I wanted to draw a quick sketch, it probably would look, and this is not exact, something like this. All right. And again, it's not an exact sketch, but the sketch of the graph kind of gives you a good idea what's going on. All right. Now, next thing we're going to do is actually figure out what it is in factored form. So, how do I get my factors from my what? Roots. So, my roots are negative 3 and 4. So then my factors, what do you think my factor would be for negative 3? What's my factor that would give me a root of negative 3? X plus 3. We just switched the sign. What's the root that would give me positive, or what's the factor that would give me a root of positive 4? X minus 4. So if we were to write this in factored form, we get y equals a times x plus 3 times x minus 4. Now, the reason we put a in front of it is because, remember, there's always a constant, or we hope that there's a constant, but we have to figure that out. All right, that's where this a value comes in. We have to figure that out. So until then, you can't say that the function is just x plus 3, x minus 4, because we got to make sure there's no scalar or a value. All right, or if the a value is just 1. Now, just from the factors, we know that a quadratic function has a degree of what? What's typically the highest exponent in a quadratic function? 2. Based off of the x, what we have currently, will we have a degree of 2 with our factored form if we added up the exponents? So like this is currently an exponent of 1, this is an exponent of 1. Yes, no? So Jasmine says yes. Anyone else agree with her? So if we add up the exponents, we get what? 2. 1 plus 1 is 2. All right. So we meet the requirements. We got a degree of 2. We can also look at our dance moves. What type of dance move do you think is going on here? Someone besides Jasmine. What type of dance move is going on here? It's a cross. What about here? Cross. And cross gives us exponents of what? 1. So it still lines up. They don't have exponents pretty much. Now, we need to figure out what the a value is. For that, we're going to use the point that it passes through. That's how we're going to find a. How do you think I'm going to use that point? With what I have currently. So we got the point, and then we also got this part of the function. How do you think I'm going to find a using that point and my current part of the function? So think about it. What's a point typically written as? How do you write a coordinate? What do you put first? Right, it's the form xy. So couldn't we plug 2 in for x and 50 in for y and solve for a? Yes, no, maybe? What do you guys think? So if x is equal to 2, y is equal to negative 50, we can then plug those in to our current function and solve for a. So I'm going to do that. So I have negative 50 is equal to a times 2 plus 3 times 2 minus 4. So let's do some simplifying before we get into the solving part. So negative 50 is equal to a times, what's 2 plus 3? 5. What's 2 minus 4? Negative 2. So this would be negative 50 is equal to a times negative 10. How do I solve for a? Someone besides Jasmine. How do I get the a by itself? You may recognize it better as this. How do I get the a by itself? Say it one more time. Not add the 10. Divide by the negative 10 because we're multiplying the negative 10 to the a. So we're going to divide both sides by negative 10. So my a is equal to what? What's negative 50 divided by negative 10? Positive 5. So my factored form is y is equal to 5 times x plus 3 times x minus 4. That's what my function is in factored form. So this is what it is in factored form. However, what did the problem ask us to find our function in? What did it ask us to find it in? Standard form. Now, this is review from both Math 2 and definitely Math 1. How do I go from factored form to standard form? What's the easiest way? Well, we're not going to distribute the 5 just yet, but you're on the right track. What operation are you typically doing when you distribute? Multiplying. How do you multiply factors together? Learn this way back in Math 1. What methods could you use? Box method or FOIL. All right. So I'm going to box the 2 factors first and then multiply that entire thing by 5. So I get x plus 3 on top, x minus 4 on the side. What's x times x? X squared. 3 times x. 3x. Negative 4 times x. Negative 4x. Negative 4 times 3. Negative 12. And remember, your like terms are always in the diagonal. So if I'm just going to combine like terms when I pull it out, I get x squared. What's negative 4x plus 3x? Negative 1x or negative x minus 12. But I'm not done yet because I still got to multiply this entire thing by 5. I got to drop that 5 down. So how do I distribute? Well, I just said it. So to get rid of the 5 in the parentheses, we just need to distribute 5 to all the terms. Huh? Yeah, I was about to say, what do we do next? And I said distribute. So what's 5 times x squared? 5x squared. 5 times negative x. Negative 5x. 5 times negative 12. Negative 60. So this is our function in standard form. So my suggestion to you is if they're trying to find a function, find it in factored form first. All right. because then getting it into standard is easy. All right, so factored form first because that's the easiest thing to do if you're given the roots, and then convert it to standard by doing box method or foiling or whatever. Any questions on that? All right, now let's look at these quadratic polynomials and see how the a value affects the graph. So, what are the x-intercepts of this parabola? All of these have the same x-intercepts based off of this right here. What are they? So we're going from factors to roots. So if my factors are right here, these are my factors. What are my roots? Or x-intercepts? What are they? -2 and +5. Now, let me ask you this. What do you think the difference is between these three? This is a review on transformations. So we're multiplying an a value out here, and the a value outside this one is just 1. What happens when you multiply a whole number outside of the brackets? It's a dilation, but what happens to the graph itself? Does it stretch or compress? It stretches or it gets thinner or wider. So guys, if I'm stretching vertically, remember, look at me. Remember the rubber band example. If I stretch vertically, does the rubber band get thinner or wider? Thinner. So if you multiply a whole number to it, all it does is it makes the graph thinner. So this one is thinner than this one. And this one would be thinner than both. All right. So that's all it does. It just makes the graph skinnier. Because of the a values right here. That's all it does. Again, that's just review from Unit 1. Now, let's do a cubic graph. So, yeah. Okay. So, we're going to create the equation of a cubic function in standard form with the x-intercepts of -4, 2, and 5, and it passes through the point 620. So before I do anything, I'm at least going to sketch my points so I have an idea of what's going on. So I got my x-intercepts at -4, +2, and +5. And then a graph somewhere at 6. So 6 and then 20. So about here. Now, I'm not going to sketch my graph just yet because I need to know some things that are going on. All right. First off, what's the degree of a cubic function? 3. Why do you think it's 3? What does a cubic function typically contain? An x cubed. Good. So a cubic function typically contains an x cubed somewhere in it. So that means its highest exponent's 3, so its degree is 3. That's why we have 3 roots. All right. So, and it passes through the point 620. So first things first, we're going to put it in factored form. Now, a function can only have the number of zeros, all right, that matches its degree. All right. So there's 3 zeros and we have a degree of 3. That's very important when we talk about exponents. So first off, my factors. What's my factor for when x is equal to -4. So if my root is -4, what's my factor? Someone beside, let's go with, well, Jasmine, you got to look at the draw. What's my factor for x equals -4? X plus 4. All right. Now let's go with Vanessa. What's my factor for when x is equal to 2? Close. X minus 2. So remember, you just want to flip the sign. All right. Then Corey. What's the factor for when x is equal to 5? X minus 5. So these are my 3 factors. Now, based on just these 3 factors, what's the degree? Currently. 3. Does that match the degree we're going for? Yes. So I'm going to assume that we don't have any exponents. So that means when it passes through, since there's no exponents, they're also all crosses. That's how they pass through, all crosses. But we don't know how the crosses are going yet. So now my factored form is y equals a times x plus 4, x minus 2, x minus 5. Now we need to solve for a. What do I do to solve for a? Let's go with testing. Blake. What do I need to do to solve for a? What do I use? What did I use in the first example? So up here, what did I use to find the a value, or the blue? I use the factored form and the point that it passes through. All right. So I'm using the point that it passes through. Why is this thing being dumb? All right. So let's go with Luna. If I'm using the point that it passes through to find my a value, how do I plug it in? I plug in what for what letter? Right. Right. So 6 is my x value, 20 is my y value. So 20 equals a times 6 plus 4 times 6 minus 2 times 6 minus 5. All right. So do some simplifying here. So this would be 20 is equal to a times 10 times 4 times 1. So we're essentially just doing 10 times 4. So 20 is equal to 40a. Divide by 40. What does 20 over 40 simplify down to? 1/2. So my a value is 1/2. Thus, my completed factor form is y equals 1/2 times x plus 4 times x minus 2 times x minus 5. Help if I actually put the correct number. All right. So that's my factored form. Now I need to get my standard. All right. So standard form, like I said, we're doing box methods. How many box methods do you think I'm going to end up doing? So when you do the box method, we're going to have to do the box method more than once here. How many times do you think I'm going to have to do it? Twice. Because you can only use 2 factors at a time in box method. So I'm going to do the first 2 first. So I'm going to do a box for x plus 4, x minus 2. What's x times x? X squared. X times 4. Negative 2 times x. Negative 2x. Negative 2 times 4. Negative, not 6. 8. So if I pull it out, this would be x squared plus 2x, if I combine these like terms, minus 8. Then I'm going to multiply that by x minus 5. So that's my second box. So I have x squared plus 2x minus 8 all over x minus 5. What's x times x squared? X cubed. What's 2x times x? 2x squared. Then I got negative 8x, negative 5x squared, negative 10x, and positive 40. And again, what I love about box method is that your like terms are almost always on the diagonal. So my x squareds are already kind of together, my x's are already kind of together. So when I pull it out, I get x cubed minus 3x squared, if I combine the negative 5x squared, the 2x squared, minus 18x, if I combine the negative 10x and the negative 8x, plus 40. Now, I'm not done because I got to do one more thing. What's my last thing I got to do? I got to multiply this all by 1/2, which is my a value. So essentially, you're dividing all the terms by 2. So, my y equals 1/2 x cubed minus 3 over 2, because that's 3 times 1/2, x squared, minus, what's 18 divided by 2? 9x, plus 40 divided by 2, 20. And there we have it in standard form. Now I can draw a little bit more of my graph. So first off, what's my y-intercept of this graph? 20. How do you know? Y is 20, obviously our y-intercept. Because it's our constant. So our constant in standard form represents our y-intercept. So our y-intercept would be about right here. Now I kind of got enough information. Yes. Right. Go ahead. Yeah. Now I kind of got enough information to draw my graph, or at least sketch it. So I'm thinking my graph looks something like this. Now remember, all of your dance moves here are crosses. So I'm going to assume my graph looks something like that. So there's no bounces as you're going through the X's or squiggles. They're just crosses. So I think that would be a decent sketch of our graph. Any questions? All right. Last thing I want to go through, and we're not going to go through the entire process of putting it in standard form. I just want to at least put this one in factored form. All right. Because it's just how the wording is. So we're creating an equation of a cubic function in standard form, or in this case, we're just hoping for factored form, that has a double zero of -2 and another 0 at 4. What's another name for 0? X-intercept or root. And then it has a y-intercept of 16. All right. So still doing cubic, so the degree is 3. Now, again, for this one, we're not going to worry about standard form because it's the same process to get into standard form. I only care about factored form right now because that's probably the hardest part, is the factored form. All right. So if we're doing the factored form, first off, what does it mean when we says double zero? What do you think that means? So it's a double zero at -2 or a double root at -2. What do you think that means? Think dance moves. What would that dance move mean if it was a double zero? So what does double mean? Times 2, right? Or twice? That basically just means you count the -2 twice. So your roots, you have 2 -2s. All right? It counts twice. So when we convert it to factors, what would I write? So what's -2 as a factor? X plus 2. And since we're counting it twice because it's a double zero, I'm going to put another x plus 2 because we're counting it twice. And then we have another root at 4, and it's only counted once. So what's 4 as a factor? X minus 4. Now, how could I rewrite this so that it has an exponent? If I'm multiplying something by itself, that's the same thing as doing what to it? Squaring it. So I can rewrite this as y equals a times x plus 2 squared times x minus 4. So you may see double roots. You may see triple roots. All that means is count that root that many times. All right? That's basically all that means. So double zero, you're counting that -2 twice. If it was a triple zero, you'd be counting it 3 times. What dance move would that be if it's x plus 2 squared? That'll be a bounce. So when we graph it, we'll have a bounce somewhere. Because obviously on the graph, if we just graph the zeros right now, you can only graph -2 as a zero once. But the bounce is what shows that it counts twice. All right. So now we're solving for our a value. Now, they don't say that it passes through a point, but they still give us a point. What do you think the point is? What part of the problem gives me that point? Landon. The y-intercept. Because the y-intercept's a point, and our graph obviously goes through the y-intercept. How do I write the y-intercept as a point if it has a y-intercept of 16? What's that as a point? 0, 16. So now I got a point that my graph passes through. So I'm going to solve when x is 0 and y is 16. I'm going to solve for a. So I have 16 is equal to a times 0 plus 2 all squared times 0 minus 4. So just to solve it fast, this will be a times 2 squared times -4. 16 is equal to a 4 times -4. So 16 is equal to -16a. Divide by -16. A is equal to what? Not just 1, -1. We're dividing by a negative. So my final form would be negative a, not negative a, -1 or just negative x plus 2 all squared times x minus 4. Now, since it's negative and it's a cubic function, what's my end behavior going to look like? So going from left to right, is it going to start high and get low, or is it going to start low and get high? Based off of your end behavior. Think about it. What typically tells us the end behavior? So obviously it's whether it's an odd or even function, which cubic's obviously an odd. Like kind of. What was the other part of that card sort yesterday? So it was whether it was odd or even. What was the other part? Positive or negative? What type of function is this? Negative. How do you know? Our A value is negative. So that's our A value is part that determines in behavior. Because we know it's a cubic, so our ends are going to go in different directions. My right side of the function will be going where? Up or down? Down. My left side will be going where? Up. So if we drew this, and we're going to have our x-intercept at 16, it would look something like this. Now, don't forget, you have a bounce at -2. So you just bounce right back up. You're going for a little bit. You go back down, and it crosses at -4 because it's only counted once. So this is what your graph would look like. That is not quadratic. Nope. Because remember, we have to add up the exponents to get our degree. So look at the factors right here. How many factors are there? If we wrote it all the way out. 3. How many factors are here? Nope. Still 3. That square just means we count this factor twice. So another way to do it is to add the exponents. This has an exponent of 1. What's 2 plus 1? 3. All right. Any questions on any of this? All right. So you got 15 minutes left of class. So you can continue to work on that Delta math or finish up that quizzes if you'd like. And I'll post your exit tickets.